Today was the first day of summer, and it's a beautiful day. So this is the summer solstice. It's the day for the northern hemisphere when we have the most daylight, and in the southern hemisphere it's the winter solstice. So it's the first day of winter, astronomical winter, in the southern hemisphere, and it's the first day of summer in the northern hemisphere. Of course, we're in the northern hemisphere. And the sun will be setting, it's the longest day, so it's like, I don't know exactly when sunset is. I would have to check to get the exact time. I should have checked that before I started the video, but we're going to see, the sun is, because it's cloudy, you're probably not going to see a sunset today, and it's still for a couple more hours. The sun's way up here, and it's already late, late, it's after 5 o'clock, and the sun's still way up in the sky. So it's still a couple more hours before it starts getting down here. And I think because it's cloudy, you'll really won't see the sunset. But anyhow, when it does, it'll be setting as far to the north as it will all year. And that's really interesting because it tells you something about the cycles that are related to the seasons. We have our seasons because of the amount of solar energy we're getting hit with at any given time. So when it's summertime, we get the most direct sunlight, and that's the most energy coming from the sun in the form of photons mostly, and other electromagnetic spectrum, UV radiation and whatnot, hitting the earth and causing all the little molecules in the air and on the ground and everything to bounce around and to vibrate and to put off heat. So the energy from the sun hits earth, and everything starts to vibrate because there's that energy then has to go somewhere, and it turns into heat energy. And because we have an atmosphere, and just the right atmosphere, the heat, some of it stays trapped instead of just going off into space, because in space is it's a big vacuum. And so if we didn't have an atmosphere, of course we couldn't breathe, but it would be just like being in outer space. The energy just wouldn't stay here. Some of it would get trapped into the ground, but not for very long. It would just hit the ground. The ground would get warm, but then it would just evaporate off. And that's why comets and things like that are just ice balls. And the same thing with small planets that are far away from the sun. They're pretty much just icy little, like Pluto doesn't have much of an atmosphere, so it's really icy and cold, and it's a very long ways from the sun, so it doesn't get as much sun energy. But even Mars, which is pretty close to the sun, it's not as close as Earth, but it's close enough that it would be warm on Mars if it had a thicker atmosphere. And then Venus has a very thick atmosphere, and it gets and it's a little closer to the sun, but mostly it's got a very thick atmosphere, so it gets a lot of heat energy, and it's very hot on Venus. Anyhow, energy. I love you.